All right, dude. Let's see. So we are going to be graphing this. So we're going to start out with our first thing is finding symmetry. Symmetry is going to be simply plugging in a negative x into our function and see if it turns out to be the same. So if we do that, we'll have g of negative x, and then I would just put in wherever I saw an x, I'm going to now place a negative x in there. Notice that that negative x is inside the parentheses and it's being squared. So a negative times a negative becomes a positive. So we end up having a positive x squared here. Those are the same so far, nice. This, however, a negative and a positive becomes a negative x, and then we have r minus 2. There's not really much thinking to this one, you're just plugging it in, and there's no solving or anything like that. So we see that these are slightly different. So there is going to be no symmetry here, no symmetry. So for our first one, we have no symmetry. And I'm just going to box in our answers as we go, which I recommend you do as well, because it'll keep you from losing track of your stuff. So that's our first thing. And let me see, I'm going to, I'm just going to continue down the board like this. Okay. Our second thing that we're looking for is our y-intercepts. So, and I'm going to put in red under here. All that we're doing is it's basically this right here. We just put in a negative x, and you're just comparing is all you're doing. Right. So down here, we are looking for our y-intercept. So our y-intercept is based off of letting, if we have our xy coordinates, we have our y and our x. To find the x-intercept, we have to let this value of x be 0, and we can see what's crossing at the y. So that is what's happening on our second one. So now we would let the x, let x equal 0 to find our y-intercepts. And also too, okay, just making sure it's visible. All right, so now we take our function and we just let those x's be 0. So if I'm down here and we have our we'd have wherever our x's are, we're going to be putting in our zeros. Those cancel out, and we're left with a 2 over a negative 2. We know that anything over itself is 1, and then we still have that negative to account for. So this is a negative 1. Now remember, this is a y-intercept, which means that it's a point, right? And we just let x equal 0. So that means that our actual y-intercept is going to be no x's, and we put in a negative 1. So our y-intercept is that point right there. All right. Moving on, we have, and then I'm going to box this off right here because this is our thing we're working with. Okay. And now we're over here on our third step. I might box this in as well, just to kind of keep some, just so we can have our stuff separated or whatever. Because now we're over here on 3. Let's get it over now that I have it there. Our third thing is we are finding our y, our x-intercepts. So we're looking for our x-intercepts, okay? Now, by the same token of letting x's equal 0, right, when you're here, we have to let that x be 0 to come here. Well, if we let y equal 0, we can cross here at x. And that's, we've been doing this for a little while, so that concept should be settling in by now. And so we're letting y equal 0. But what's interesting about this, and you'll see it on your packet that Professor Lopez gave you, is that she has identified this top portion as a p of x function. This bottom portion has been notated as a q of x. Let me scoot this over a little here and put these on top of each other. Okay. Well, what's nice about these fractions is that when you if you let the y be 0, so if we take our original function and we have our g of x is equal to 2 over x squared plus x minus 2, right? Typically you're used to having just a polynomial without this fraction, and we turn this guy into 0, and we say, hey, 0 equals this 2 over x squared plus x minus 2, right? There's not too much of a need to do this, depending on how you want to go, but Professor Lopez she has this statement there, and it says, basically you're setting p of x equal to 0, which all that means is we're setting the top part equal to 0. Why? Because any fraction, if you have 0 and then you have anything underneath that 0, it always equals 0. So underneath doesn't really matter that much, but the top matters. So if we just set the top, or p of x, equal to 0, we will find our answer. And then you may already be ahead of me, but you're noticing, like, hey, if I just set this top portion equal to 0, here, let me get rid of this. If you set the top portion equal to 0, you would have a statement that says 0 equals 2. That is not a true statement. This is it's not true. Well, if it's an invalid statement, that actually implies that there are no x-intercepts in this case. There are none. However, if there was an x value there to solve for, then you would end up having some of those values. So here, this is not a true statement, so therefore we do not have any x-intercepts. I'll put it right here. We have no x-intercepts. I'll box that well, that's, wait, no, that's not true. So I'm gonna get rid of that, just to keep space. I know I have a lot of board, but you never know. So here, all right. So now our fourth thing that we're going for is we're looking for vertical asymptotes. We have we're looking for vertical asymptotes. Now, vertical asymptotes are vertical. They stand up. Professor Lopez has a saying where she says, you know, X's stand up, her story about from childhood, and Y's lie down, kind of thing. So this vertical asymptote is happening with a slope value of 0. And if you recall, zeros or slopes that are up and down are 1/0. That's what our slopes equal. So kind of opposite of our other case over here where we set the top equal to 0, we're actually going to set the bottom equal to 0 on this one, and that is going to give you your values for your vertical asymptotes. So we're going to take the bottom, which is also our q of x, part of that fraction. So if we have q of x and we set that to 0, or the bottom, we would have our x squared plus x minus 2 equals 0. Ah, yes. And now we're back into a very comfortable part of algebra. We're solving for x, and it's your standard kind of polynomial that you've been dealing with for a long time. There's only 3 ways to solve these. You can only solve these through quadratic formula, factoring, or completing the square. So on this guy, I am going to factor it for the sake of time. It was like, does this one factor? And indeed it will, because you can think, what are the multiples of 2? Well, you only have a 1 and a 2, right? And then you're sitting here thinking like, what can multiply to give me -2 but add up to a +1? Well, if I have this guy positive and that one negative, these multiply together give me my -2, and then if I add these up, I will get my positive 1. So we then make our fraction, or not fraction, but a factor. This first one of those guys, this one, and one of those guys. Right? So double check, x and x squared, 2x minus 1x gives me x, and then -1, -2. Fantastic. So then, as you know, whenever we take these two guys, we set them both individually to 0. When we do that, we get x equals 1 and x equals -2. Nice. These are where the asymptotes happen. So these are not points, not like our y-axis. It's not a point, but it's an entire vertical slope, right? Because we have 0 on the bottom of the fraction. We have, if that's 0, it'd be 2/0 that's standing straight up. And these locations are where that happens. So here we have our vertical asymptotes. I'm just going to put our vertical asymptotes right here. And we have our vertical asymptotes right there. All right. Awesome. Okay. So I'm going to box that guy off there. All right, now we're on to our fifth part. our fifth part is a somewhat complicated looking. Let me make sure, is everything running? Are we still good? Yes. Okay, nice. Okay. 5 is not as difficult as it seems. We have this condition where we're assigning an n and an m, and we have an m. And these n and m's are the exponents, the leading exponents of these terms is what they're going to be. So what I mean by that is we have, I'm going to take our function. Over here. Let's take our function. We have our we have the x squared plus x minus 2, right? Okay, so what we're looking for is the, let me put that, make it more look like a exponent. There we go. All right, so we're looking for the leading x term, not a constant, but the x term, and we are looking at this exponent. Notice that there's no x up there. There's no x. So we're calling this guy where we have some kind of coefficients where this guy is our m and this is our n, right? Let me double check so I make sure that looks like y'all's notes. Yeah. So we're calling the n in our numerator. So we have these statements where we have n is less than m, we have n is equal to m, and then we have n is greater than m, okay? And so all we're doing is looking at the exponential value of the leading terms. This one doesn't have one. So that means that our n would end up being 0. So we would put in 0 for our n, and then our m is 2. And this is just saying that our top is smaller than our bottom, is what it's saying. When that happens, you have a condition that says this guy, actually let me write the conditions, I'm going to kind of scoot this stuff over. So when we have n, or let's say this is the top, right? The top, and this is the bottom. So basically, top is less than the bottom, right? And that means that you'll get this, that means that y will be 0. And remember, right here, we're talking about our horizontal asymptotes, is what we're talking about. So when the top is smaller than the bottom, we have an asymptote sitting at y equals 0, which would be basically the x-axis. When they're equal to each other, and I want to make sure I get her, yes, we have this an over bn, and this is just fancy jargon that's saying we're taking the, let me write my, up here we have 2, and we have x squared plus x minus 2. Alright. So all this is fancy jargon was saying like, hey, take the lead coefficients and make a fraction out of them. So here we have a 1 sitting in front of that guy. So on our bottom here, we're going to have a 1, and then this is our, let me write, just to explain this part a little bit more, I'm going to write just something generic. Let's pretend that there is an x right there, okay? And we have an x squared plus x minus 2. And we're looking at these guys right here. This bottom one is my m, this top one is my n, right? So we have 0 is less than 2. or no, sorry, we're doing an example where these are equal. That's what we want. Okay, so if 2 is equal to 2. So it's saying take this first guy and then take the coefficient in front of that one over 1, and we would get 2. So we would have y equals 2. We would end up getting y equals 2. And that's where our horizontal asymptote is in that case. So this one's just basically make that fraction. That's what that means. And then when it's here, it's real nice. If the top is bigger than the bottom, then you have no horizontal asymptote. So in this case, we see that the bottom is, or the top is in fact smaller than the bottom. So our answer ends up being a y equals 0 for our horizontal asymptote. So here we have y equals 0 is our horizontal asymptote. And I'm going to box that one in. Awesome. All right, so now we are ready to graph. See, there should be enough space right here. All right. Okay, so now our x. Okay. The best thing, and now all of the information, we found all this information, right? And we are going to plot it and kind of make a scaffolding before you get started. So I always recommend starting with your vertical asymptotes and your horizontal asymptotes. So our horizontal asymptote is y equals 0. So when y is 0, we have the y's lie down horizontal asymptote. Okay, and then we have 2 vertical asymptotes, one at 1 and one at -2. So I'm going to put this as my 1, and then we have 1, 2, then we have a -2 sitting there. Or we're going to have these vertical asymptotes here. Nice. And so as we do that, I'm just going to go, I'm going to say, hey, I used that, I used those. Okay. All right, and so now let's go ahead. We don't have any x-intercepts. Nice. And then we have our y-intercepts are at 0, or we only have 1. We have 1 at 0, -1. That means that we're going to come down here to, let's call that -1. And we're placing our y-intercept right there. Right on. Okay. Now, the only thing, and also too, there's no symmetry. Just this part is kind of like it's there's no symmetry, and all that means is that it's not symmetrical about the y-axis, right? And as you can see right here, these are it's kind of shifted over. You're not at -2 and 2, where this would be evenly split. So it's just moved over a little bit, and that's just confirming that there's no symmetry in the problem. So no symmetry in this problem. Nice. And we've used this, and we don't have any x-intercepts, so we've used all of our information. Now, the thing to do, and I'm actually going to, just to make a little space, I'm going to erase this part. Okay. And we want to make an x, y table. And the best thing to do is you want points on every side of the vertical asymptotes. Here, here, and here. And you can go ahead and put them in there. And I think Professor Lopez does this in red. She'll come through here and go, our vertical asymptotes are at, we have x equals 1, and we have an x, let's do the negative first. The negative, that one and this one, and we know that these are this is, I can't spell, asymptotes. All right, so we have these guys right here. Okay? So now we just want to plot stuff on either side, as you can see. I might not have made enough space right there, but that's all right. Cool. So, and I'll grab mine. I like to have a calculator to make sure that I don't make mistakes. All right, and we are going to plug in some points to the left of -2. I'm going to put it in 2 different points. I'm and just for the fun of it, I'm going to put in a -10 for one of them. You can go out far. Actually, no, let's not do that because let's do more like, let's do like a -5, right? And then I'm going to do one that's like -3. I'm going to do that. Then I want to put some more points there. We do have one y-intercept right there. I'm going to scoot this down. And I'm going to put in like, I'm going to probably put in like a 1. We know what 0 is. And then I want to put in like a, oh yeah, and this is a -1. And then, but here we know 0. I kind of want to know what's happening on to the right of that, just to make sure. So I'm actually going to put something in between 1 and 0. So I'm going to put a half in. So you can do it as a fraction or decimal, doesn't matter. And then I'm going to come to the right here, and I'm going to put in something like probably like 2, and maybe like, I don't know, 2 and 4 or something. You know what I mean? Kind of stretch it out a little. Okay. So I'm just going to do a little calculator work so I don't make a mistake, and I'm going to plug in these values here, and we're going to find out that when we plug in a -5, sure I did that right, -5, yes, we're going to end up getting a 1/9, which is also in decimal, is like 0.1111, that kind of thing. So, and actually, yeah, you can see that. So this is a 1/9 for my y. So I'm going to come over here, which is very small. So out here at -5, let's just call that -5, and this is going to be -3. I've got something that's just barely sitting above there. All right. Now when we plug in -3, we're going to get a half, or 0.5. So we'll get a half of that. So it's going to be higher up than that guy. It's going to be up here at like something like that. And you can kind of see that this guy is trending up, and it's going to have to scooch on up there. And so my proportions aren't all that great, but we know that that guy's going to look like that. Now here, let's plug in a -1. And we get a -1. So we have a 1, and we have a -1 right there. That is a little bit kind of like not super clear, because you have something that looks almost like a straight line right there, and it's kind of like, what is that doing? That's not really giving me any direction. So if something like that happens, I would just do something in between here now, because like, what does it look like right here? So I'm going to put in a -1.5 and see what happens. And so I'll just do it to the side. We're going to have like, if I put in a -1.5, what do I get for that y if I do that? negative 1.5. And we'll get a negative 8 over 5. Which in decimals, that's a negative 1.6, negative 1.6. So when I'm over here halfway in between, I'm a little bit more negative than that guy. It's going to be somewhere like this. And then you're like, ah, that's better. You know, now I can see that that guy is for sure trending that way. But what's happening right here, and this is when we'll put in our 1/2. So we're going to take 1/2, so x, and we get a 1/2. Yes. Oh wait, sorry. I was about to say that's not right. One second, I didn't put it in my equation. There we go. We get a negative 8 over 5, which is the same value that we got over here. So we get a negative 1.6 or an 8 over 5. Same thing. Okay. And so we get something that's right here, and then you go, ah, much better. We're getting something that's doing this kind of thing, like that. Nice, okay? Now all we have left is to plug in 2 and 4. If we do that, we get a 1/2. So if I put in a 2 right here, we're going to get a 1/2, which is not real 1/2 there, but it's right there. And then I'm going to put in a 4. Gives me 1/9, that same kind of distance thing over here. So I put in like a 4 or whatever, and we've got this guy a little bit low. Oh, I'm changing colors here. So we know that this is gonna have to appear like that. And there you go. That is graphing number 67. And I think on the answer key there's an error. This is actually pointing up, and that's actually incorrect. This is that is your answer right there. All right, guys. So good.